In a previous video, we focused on whole number addition, models and properties. In this video, we're going to extend that and focus on whole number multiplication models and properties. Just a reminder, whole numbers are the counting numbers, 1, 2, 3, 4, on up to infinity, and with 0, which is a whole at the end. So there are a couple different ways you can represent or depict multiplication. One is using sets, so a set model of multiplication. In these images, I'm depicting the product 3 times 6. So 3 times 6, there you go. 3 times 6, one way to depict that is 3 sets of 6. So in the figure on the left, I've got 3 sets, each of which depicts 6 stars. So 3 times 6, 3 sets of 6 would be the total number of stars in the 3 groups. So that's going to be 6 in the first, 6 in the second, and 6 in the third, which is 18. That also illustrates that multiplication, one of the key principles, multiplication is repeated addition. On the figures on the right, I'm using an array model, just essentially sets of dots to illustrate the product. I've got 3 sets, each row representing a set, 3 sets of 6 dots. So they're basically just the same as the other set model, the one on the left. In this case, if you just envision the rows as being the sets, 3 sets of 6, the total number, 3 times 6, or just the total number is 18. The advantage of an array model is you can flip it, like I've done here on the bottom, and rotate it, I guess you'd say. And this 3 sets of 6 is 18, but if in this model on the bottom right, I've got 6 sets of 3. And so on, all the way down to the bottom. And notice that all I did was rotate. The number of dots doesn't change. This is also 18. And so the array model is a terrific tool for depicting or sort of illustrating a key property of multiplication, which is called commutative property. The other way to represent multiplication is with number lines. And I think number line models are an ideal way to make a transition from concrete mathematics to mathematics that's more abstract. In the number line model, again, you use multiplication as repeated addition, so that 3 times 6 would be equal to 6 plus 6 plus 6, and you represent that on the number line. Okay, so you say, okay, I'm going to start at 0, that's my starting point, and I'm going to take 3 jumps of 6. So 6 would take me to there, add another 6 would take me to there, add another 6, there you go. And again, just pretend that you're walking up the number line 6 steps, takes me to there. So 6 plus 6 plus 6 is equal to 18. So in other words, the product 3 times 6 would equal 18. There are a few key properties of multiplication, and we're going to just discuss these now. The commutative property, A times B equals B times A. So as we just discovered, 3 times 6 equals 6 times 3. The order in which you multiply doesn't make it different. The closure property, if A and B are whole numbers and you multiply them, A times B is also a whole number. The zero property, which says that A times 0 equals 0 times A equals 0. So any number times 0 equals itself. And that's a little different because in addition, 0 is the identity element, meaning A plus 0 equals A. In multiplication, A times 0 equals 0. For the continuing the properties, sorry, I had to erase a few things there. Continuing the properties, the identity property of multiplication. So identity doesn't just mean that we had identity for addition, which was 0. For multiplication, identity is 1. And that is essentially the definition of an identity is A times or operated on by 1. So A times 1 equals 1 times A equals itself. Now, so 1 times anything, so 1 times 4 equals 4 times 1, which equals 4. The associative property, similar to addition, says you can group these in different ways. So if I want to take, and this is one of the key misunderstandings that students have. If I want to take 2 times 5 times 3, I could say that's 2 times 15, which is 30. Or I could regroup those, group those differently. So the 2 and 5 are associated. Times 3. 2 times 5 is 10. Times 3 is 30 as well. So the order in which you group the whole numbers does not change the outcome. Lastly, the distributive law. And notice I've got it sort of stated in a complex way. That is that plus and minus means that it works for plus. It also works for minus. So, for example, if I take, and what's great about the distributive law, it's a great way to do mental math. So if I take 3 times 13, for example, well, we can expand 13. That is 3 times 10 plus 3. And now I can distribute. And this is what many people do with mental math. You say, well, that is equal to 3 times 10, which is 30, plus 3 times 3, which is 9. So 30 plus 9 equals 39. Now for the multiplication, that would be an example. Okay, so what is 6 times 49? All right, you could represent that as a plus, or you could represent that as a minus. So I could say that is equal to 6 times 49, I'm going to say is 50 minus 1. And so 6 times 50 is 300, minus, again distributing the 6, minus 6 times 1, which is 6. 300 minus 6 is 294. Okay. Let's finish up this video by using a few of the properties. So some sample homework or test or quiz type questions. Are the following sets closed under multiplication? So the first set, -1, 0, 1, is closed. Because in multiplication, if you take any two numbers and multiply them together, you should get another number in that set. So for example, if I take -1 times 0, that gives me another number in the set, which is 0. If I take -1 times -1, because you can multiply the same element by itself, that equals 1, which is also in the set. -1 times 1 equals -1, which is also in the set. So any two elements I pick and I multiply them, this is under multiplication, would give me an element back in the set. So it is closed. The second set is not closed. And we've talked a little bit about counterexamples. A counterexample would be two numbers. If I pick two numbers and multiply them, I get something that's not in the set. So I'm going to pick, let's say there's lots of examples, 2 and 2. Remember, you can pick the same one twice. So 2 is in the set and 2 is in the set, but 2 times 2 equals 4, and 4 is not in the set. So this is not closed under multiplication. How about the multiples of 5? 0, 5, which you often do with young kids. You start skip counting. 5, 10, 15, 20, and you start going up. So are these values, is this set rather closed? Turns out it is. If I take any number, so I can represent these as 5. The first one, 5 times something, because 5 is 5 times 1. 10 is 5 times 2, and so on. So if I take any two numbers, 5 times, we'll call it I, and I multiply that by another number, 5 times J, oh, sorry, 5 times j, excuse me. That equals, now I'm going to take out a 5. That equals 5 times I times 5j. Now what's nice about that is, remember, whole numbers are closed under multiplication. So this is another whole number. We'll call it w. So this is 5 times w. What 5 times w is just an element in that set. So if I take any two elements in this set and multiply them, I'm going to get another element which is equal to 5 times something. So this is closed. Lastly, we'll just say which properties are illustrated here. 4 times 5 times 1. What I do is I look for what's changed. I've got 5 times 1, which equals 5. That is the identity property. And I think it's important you say which operation. Identity property of multiplication. 0 times 3 times 6. Well, you say it kind of looks like it should be associative, but what it says, that equals 0. 0 times anything equals 0. That is the 0 property of multiplication. 3 times 4 plus 3 times 7 equals 3 times 4 plus 7. That is the associative law, or the distributive law, excuse me, going backwards. Remember, you can go forwards. 3 times 4 times 3 times 7 equals 3 times 4 plus 3 times 7. This just goes backwards. Basically, the distributive law is the basis of factoring out common factors. So that is the distributive property. And lastly, 4 times 5 times 6 equals 4 times 6 times 5. What's changed here? The 5 times 6 equals 6 times 5. That is the commutative property of multiplication. And that's those are some examples of using properties of multiplication.